Hello students, this is the TermWork2 of your software engineering testing lab. So in this TermWork, we'll use to develop a test framework for the triangle problem. Now in the triangle problem, it accepts three inputs as the sides of the length of the sides of the triangle and determine whether the triangle is an equilateral triangle, isosceles triangle, scalene triangle, or they do not form the triangle at all. Okay, so the test cases that we'll be deriving will be based on a decision table approach, and uh, our objective of this particular experiment will be to identify the test cases for triangle problem using the decision table approach. Okay, so there are two requirements here. The first requirement is that it should accept the system should accept three positive numbers. Okay, actually which represents the three sides of the triangle. So based on these three positive numbers, it determines whether the numbers are good enough to form a triangle or not. The second requirement is to identify if the numbers are okay, it can form a triangle, then to identify whether a triangle is equilateral, isosceles, or scalene. What's an equilateral triangle? Where all the three sides of the triangle are equal. Isosceles means where two sides are equal, only any two sides are equal. Scalene means none of the sides are equal to each other. Okay, so if it violates this condition for each of these particular triangles, suppose in the equilateral, if you give any side which is unequal to the other, then it will give an error message. Or similarly in the isosceles, checking of the isosceles case, if the two sides are not equal to one another, then it should give an error. So this type of it should throw the test cases. It should take the test cases for all the different codes here. Okay, so you have to derive three different test cases for this. Before going further, let us look into a very simple to look into the common decision table terminology. Okay, the way decision tables are formed. That is, uh, this decision table has basically a set of condition stubs. Okay, as you can see, it is indicated with a blue color. This is the condition stub, and this is the action stub. Action is indicated with the red color here. So decision table is distinctly divided into two parts. One which represents the condition stub, another which represents the action stub. Now for each of the condition in the condition stub, there will be condition entries, and these condition entries are always in binary. Okay, that means either true or false. And for the action stub, depending on the conditions in a uh, column, if column which is actually which will be considered as the rule of the decision table, these actions will be taken. Okay, so these action entries are based on the different uh, action and condition entries that it takes for the condition stub here, and depending on these condition entries, the action entries are determined, which comes as the action stub. So if the condition entries, suppose for all these three are true, true, then the action stub A1 action stub is this is to be taken, and A2 is to be taken. Similarly, for rule 2, it is like this. If the first two conditions are true and the third is false, then the action A1 and action A3 should be taken. So this way, the uh, condition stub and the action stubs works in the decision table. Okay. So to understand, it is shown with a distinct colors here. Like action stub, condition stub is given with the blue color, action stub given with the red color. Similarly, the entries of the condition table are given with the green color, and the action entries are given with a brown color. So if two rules are suppose having the same condition entries, then they can be clubbed and that same action will be taken for that. Okay. So the test cases that we write are basically based on the rules. So it is based on the columns that you enter. We will write the test cases based on the rules because rules gives rise to the actions. So depending on the rule, we'll check whether a particular test applies or not. Okay. Now let us design the decision table for the problem statement that we have, that is the triangle problem. Okay. So here we identify 6 different condition steps. Okay, 6 different conditions. Now the first condition is A is less than B plus C. So this must be true for a triangle to form. Okay. Similarly, B is less than A plus C and C is less than A plus B. All these three must be true for a triangle to form. If any of these is false, suppose if A is greater than B plus C or B is greater than A plus C, greater than equal to A plus C, or C is greater than equal to A plus B, if any of these, if that happens, means if this any of these conditions are false, then the triangle cannot be formed. Okay. Only when all these three conditions are true, we can go for checking of C4, C5 and C6. Now depending on C4, C5, C6 conditions, we can identify whether the triangle is a equilateral, isosceles or scaling. Okay. So here comes the algorithm of the triangle problem. That is, we have the three positive values. Okay. And we will proceed only when all the three conditions of these these three conditions here are true. Okay, so that's why there is a AND operator in between this. Okay, these are the relational operations. So if conditions, so we can AND. So all the three must be true, then only we'll go to the next step. That means the triangle can be formed. Now if A equal to B and B equal to C, then it's an equilateral triangle. If A equal to B or A equal to C or B equal to C, then the triangle form is an isosceles, because we have already checked here these two conditions. If these two conditions does not, any of these conditions does not means what? There may be the other possibility that any two sides may be equal, all the three sides are not equal. Okay, so then it goes here and it checks for the isosceles. If both these conditions are false, then it goes to the third part, that is the it prints the triangle to be scaling. So we can see the decision table here for the triangle problem. Okay, so we have all the 6, this is the condition stuff where we have all the 6 conditions here, C1, C2, C3, okay, and C4, C5, C6. Now for this, if this condition is false, then rest of this condition is does not matter actually. If it is this condition is false, it automatically forms the rule 1 that the triangle cannot be formed. Okay. If this condition is true, then we will check for the next condition, that is B is less than A plus C. Okay. If that is false, then triangle cannot be formed. Similarly, both these conditions are true. Suppose A is less than B plus C and B is less than A plus C. We need to check the third part, that is C is less than A plus B. If this is false, then also we cannot form the triangle. So after that, if all the three conditions, see here the rule 4, we have true, 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 that means all the three conditions are true, then only we need to check for C4, C5, C6. Now if all these three conditions are also true, that means what? This is an equilateral triangle. So we have a cross in the equilateral triangle. Okay. Similarly, now for everything, for since we have already checked these particular conditions for the false of these conditions, so now in every rule we will have the first three conditions true. So in the fifth rule, all the three conditions are true. These two, A equal to B and A equal to C, is true. Okay, and the third, B is equal to C is false. Okay, can it be done? Can it be like that? No, it cannot be like that. So there is a fourth action is impossible. So if A equal to B and A equal to C means B has to be equal to C. We cannot say that B is not equal to C. So since this condition is false, so this is an impossible condition. Similarly for this rule, if there is the same thing, it will be an impossible condition because A equal to B and B equal to C. Then A has to be equal to C. Since A equal to C is false here, so we have the cross here to indicate that it is not a possible condition. Similarly, we have a similar kind of condition here in the rule 8, that is, if A equal to C and B equal to C, then A must be equal to B. So if A is not equal to B means it is a impossible condition. But after that, if we have here, suppose A equal to B and A is not equal to C and B is not equal to C, that means it should be isosceles triangle. Okay. Similarly, we have two other conditions for the isosceles triangle. That is, we have suppose A equal to B. Okay. See here, A equal to B and is false. That is, A is not equal to B, and A equal to C is true. That means A is equal to C, but B is not equal to C. Okay. Then it is an isosceles triangle because we have A equal to C. Similarly, if we have B equal to C, okay, but A is not equal to either B or C, in that case, again it's an isosceles triangle. Okay. So if all the three conditions are false, that means none of the sides are equal to each other. A is not equal to B, A is not equal to C, B is not equal to C. All the conditions are false. Then we have a scaling triangle. In the test cases table, where actually we are checking for different test cases, we are generating the test cases. Okay, we have the first is the test case ID. Okay, different ID for the test cases. Here is the description for with respect to the IDs here, and the input values for the three sides of the triangle here. In this case, the input data is 3 only, and the expected output, the output which is expected, and the actual output that you get. If these two matches, expected output is equal to the actual output, then the status is success. Otherwise, the status is false. Okay. So suppose for A input, if suppose A input is not given, only two inputs are given, then it's not a, expected output is that it's not a triangle. So actual output is, if you are getting actual output as not a triangle, that means the status of the test case execution is success because the expected output and the actual output has matched. Similarly, B and C, these two test cases, 2 and 3, if we have the similar kind of things, that is, in the 2 we have B missing, in the 3 we have C missing, same, the expected output is not a triangle, actual output is also not a triangle. Both these matches means the test case execution is success. Okay, successfully uh, tested. That is they both these condition matches. The third is if the suppose C is negative. Okay, again not a triangle, success. Okay. Now the fifth one, two sides are same and one side is given a different input. Then we know that we must have a isosceles one. Okay. So the actual output is also actually isosceles. So both these matches, so it is a success. Similarly, 6 and 7 are same. If we have A and C equal, and in the 7 we have B and C equal. So in both cases, the expected output and actual output are the isosceles. So the test case is successful. If all sides are not equal, see here 1, 2, and 3, then it is scaling. Okay, both this. So it is the scaling in the expected as well as the actual. Now this condition checking for the triangle, whether it can form a triangle or not. Suppose if a particular value that you have given is quite higher, you see, the A is 10, B and C are 2 and 3. So 2 plus 3 is 5, which is less than 10, right? So it cannot form a triangle with this kind of this size, because one side is very big, bigger than the sum of the other. So this condition becomes false. So false means we cannot form a triangle. Okay, not a triangle, not a triangle, success. Same is here. We check for B and C, that is giving a higher value for B and a high value for C. Both are greater than the sum of the other two sides. Okay, that forms a output is the expected output and the actual output are not a triangle, not a triangle. So this case is successful in that case. Okay, if all the sides are equal, then we have a equilateral. Okay, so these are different test cases which are generated from the columns of the decision table that we have found. Now we will write the Java program to generate the test cases in using the Eclipse IDE. Okay, because Eclipse is a very convenient way to write the Java programs. Okay, to write the projects in Java. And it is not mandatory that we need to use Java only. We can use the other languages also to write all these test cases and all, check the test cases. But in this case, in our lab here, we'll be using the Java. Okay, and in Java provides a very convenient way of testing all these things. We'll write a Java program, a simple Java program to generate the test, the program first, the actual program, where we'll check the whether the triangle is equilateral, isosceles, or scaling, and then we'll have a test cases generated with a module which is called as the JUnit in Java. Okay, there we'll write the three different test cases to check whether the triangle is a equilateral, isosceles, or scaling. Okay, so and we'll put different values there, and we'll check whether it executes properly or not. That is what kind of whether it satisfies the conditions or not. Okay, for to be equilateral or to be isosceles or to be scaling. Now in the I'll just open the uh, Eclipse application the IDE, and I'll explain the IDE also while executing the triangle program. Okay, so just be careful and you just listen very carefully to whatever I say. That is the way it executes, because you need to do little bit of modification and you should make the program more general, okay, than what I show here. So you and rest of the program, there are some programs at least you have to do on your own using the IDE. Okay, and I'll in this program almost 70 to 80%. Suppose I have completed, you can make it little bit more general and show the outputs, proper outputs here. Okay. Now we are running Eclipse here. You can see now the Eclipse will be executed. That is Eclipse IDE will come. Okay. You can download Eclipse. Uh, it is a it is free and open source, so you can download the Eclipse one and you can start executing on the Eclipse these programs. So as the Eclipse is opening, I'll show you the steps one by one and listen very carefully and look to every step that I do. Now that browser has started. So here you go to the create a new Java project. Okay. So I've clicked the create a new Java project. Now let me give the name of this particular project as TermWork2. work 2. Okay. Now next, you just click on next. uh, you see this is the source path. Default output folder is TermWork2 bin. Okay. Now finish. So it will just redirect you to the folder where we have this project name here. Okay, this project created as the source, this TermWork2. Okay. Now in the source we can include a package. Okay. Here we can include a package. Suppose we are giving the package as P1. The name of the package is P1. Okay. So finish. So you see a package got included as P1. Okay. After this, we can include here new a class. Okay. Inside the package. So we can add a class. So we come. It is this particular screen will be shown here. That is the particular class name has to be included here. Okay. And you know that the uh, the function inside the class and the file name should be same. Okay. So the class name and the file name should be same. So we'll have to put the same name whatever we write there in the function. So let us take this as the triangle, because the class that we'll be defining is supposed with the name the triangle. Okay. Now after this, uh, just click on the finish, because we can check the project package name is P1, the class name is triangle, and the this is the source folder where it exists in the system here. Okay. So it is the finish. Now we get a template here with the package P1, the class created as triangle. Okay. Now inside the class we need to define the main function. Now here is the detailed code for the Java class triangle, where we are checking the triangle type. Okay. So we have written here the main function here, which contains the number of arguments that are being passed, like because say 1, 2 or 3, that is if condition is if argument is not equal to null, if at least one argument is passed, and that means argument length is greater than 0, so argument length must be positive, that means the values passed should be positive, then it will call another function which is the triangle type. Okay. And it identify what type of triangle it is, whether it is a equilateral or isosceles or scalene, else it is a invalid empty. Okay. So we have another function defined here, which which is the which is called by the main function, that is the triangle type. So triangle, in the triangle type we have the way we are taking the three inputs A, B and C. Okay. And checking for this with the condition whether it is a say all the three are equal means the equilateral, all the three are not equal means the scalene, any two sides are equal means it is the isosceles. So it's a very simple program, Java program, which identifies all the three different kind of triangles that is possible here. Okay. Now next objective after creating of this program, which is the main focus of this particular term work, is to create the test cases. Okay. To create a test case, you must click on this button here. Okay. And you find a JUnit test case. You can see the JUnit test case. Okay. Now click on this. Okay, now you see we have the package. Since we are I this was the main triangle Java was basically selected here, so we automatically it will take the package name. Okay, and name is the triangle test. If you are that name we are giving as the triangle test. Okay, for the JUnit to for the test case part, test case uh, module of the program, Java program. So this is done. Okay, now click on finish. Click on finish. So you'll get this particular pop-up window, that is the unit 5 is not on the build path. Do you want to edit? Uh, Not now. Okay, you'll get a template of this sort, the template that is shown here. Once you click that OK, and now what we need to do, we need to write the test here, test case code here. Okay, see that we have this the entire test case being written for all the three parts. Okay, now to execute it, run as the run configuration. JUnit. Okay, perspective preference. I am recreating the JUnit test case file. Okay, you select the actual file, the source file here. This is the source file. Okay, go here, go to this place, and click on the JUnit test case. You get this name, put the name. Now, once you have written these three test cases here, okay, we can see the JUnit part. Okay, now we'll go to the file, the triangle, test triangle. Right click here and run as the JUnit test. You get this. Okay, select the sources to save. Okay, and you see we get the output for the JUnit test here. Okay, error is 0, failure is 0, run 3 out of 3. 3 out of 3 means these are the 3 test cases, so it is 3. Okay, if there are more number of test cases, we will get more number here. Now click on this, you see the 3, that is the test scaling triangle. This one, scaling triangle, test isosceles triangle, test isosceles triangle, test equilateral triangle. All the 3 are said to be correct here. Okay, now suppose for equilateral triangle, we know that if we put here some other value, say 20, okay, now after this, to rerun, I can directly run from here. You can see this button here. Okay, now click here on this button, you get this option, that is this particular Java file is going to run. Okay, so put OK here, and you get, see here, these two are successfully executed test cases where expected output and actual output matches. But here, the third one, you can see a cross here. This indicates that expected output and the the actual output does not match. The actual output should be equal as per the definition of this file, the triangle Java file. To be this condition must be equal. But since this condition does not match because of the three input values given here, 20 is not equal to 10, so the third test case fails. So that is why it is showing cross here. Okay, that is the actual output and the expected output does not match. But in these two cases, the actual output and the expected output matches. Okay. Now for the scaling, say let us make it 10 to equal. Okay. Rerun this code again. Rerun this code again. Okay. Now see, scaling becomes false and equilateral is also false. Only isosceles is true because in the isosceles triangle only the actual output and the expected output matches here. For all the other two, scaling and the equilateral, it does not match. Actual and the expected does not match. So these two conditions, you can see the cross here that indicates that these two have failed and this is correct. This test case has executed successfully. Okay. So this is how the test case execution has to be done, and it has to be done through the JUnit module. Okay, attached to a the actual program, Java program. Okay. So in the JUnit you have to write the test cases, and it will check the test cases when you run the JUnit part. It will check the test cases against the actual program which has been written. In this case, the actual program is the triangle program. So these are the test cases which corresponds to that particular triangle program. So whatever data you give, this will be checked against that values in the actual program. So that is why the expected output and the equal output can be matched, and you can see whether the test case execution is successful or not. Okay, thank you. One more thing is that you uh, need to make this program more general and submit the refined version of this program to me. That is, you need to show the output, with pop-up windows and all. That is the suppose this expected output and the three conditions where the triangle is not a triangle. That also you should show, and this also these outputs like isosceles, equilateral. This for the isosceles triangle, the expected output and the uh, actual output matches. Suppose in these two cases it has matched, so that should show that it has matches. For either successful or unsuccessful, you can show the messages. Okay, that is in a pop-up window. So make little modification, make it more general and submit it. Thank you.